Let's go ahead and execute this command here to add that to the employee table. Okay, now let's query again the employee table, see what we got. Select all columns from the employee table, hit the execute button, and let me move this up. Look what we got. See, beautiful. The employee code, first name, last name, job title, date of hire, salary, bonus, and department that they're part of. Perfect. Isn't that beautiful? Welcome back to another video here, guys. Jimmy Shaka here again, and today we are going to talk about databases and what databases are, what they're used for, and basically why we need databases. Okay, every day we use our cell phones. Okay, we use our computers to exchange data. Okay, back and forth, whether it's you checking your Facebook account, whatever it is that you're doing, you are interacting with databases without necessarily knowing. Well, for developers, it's very essential that we know how to work with databases, or at least have some sort of functional knowledge of how databases work. Okay, so databases, as the name suggests, is a place where your data is stored. Okay, data being your records. For a company, say Facebook, a database has usernames, passwords, you name it. Okay, that's a database. So there are two main types of databases. We have SQL, also referred to as relational databases. SQL means structured query language. It's a language that is used to query databases, to pull, update, delete, or modify whatever information from the database. Okay, and so there's the SQL, the structured query language databases, and then there are non-SQL databases. Okay, so to give you an example, there are, for example, these are the few examples of SQL databases. We have Postgres, we have MySQL as examples for SQL, structured query language databases. And for non-SQL, you have, for example, for documented non-SQL, you have Mongodb, but there are other types of non-SQL databases. For example, the graph types. You have also the key value and column oriented. Mongodb is a documented, meaning is written in the form of documents with JSON syntax. With the SQL databases, you have to map out everything. What does that mean? You have to define your schema, the table that you're going to use, and how the tables are going to be related to each other. For example, there's a table of users that you have created, and there's another table of say accounts, for example. There's another table of, say, orders. Okay, and the user table is related to that table is related to the other table. So you have to define how tables are related in advance. Okay, and also the field types. Okay, for example, the field types have to be defined in advance, and also the types also has to be defined for these fields. For example, if you're going to have a user, for example, a name, my name Jimmy, as a record in the user table, you have to define and say that this is going to be a string. Okay, or if you say user Jimmy with ID number 5772, in that case, you want to say that that is an integer. Okay, so you have to define those things in advance before you start creating records in the SQL databases. The structure is predefined with SQL databases. Another problem with SQL databases is that they tend to scale horizontally with problems. It's an issue. If you have a database server here and you wanted to add another server, number 2 or 3 or 4, because you are maybe growing as a company, that's going to be a problem, because the more distributed your servers are, the more it's going to be hard for you to interconnect those tables from different nodes, because you have to define how tables are related to each other. So as you can see, that's going to be a problem the more distributed your servers are. So that's a problem. Horizontal scaling for SQL databases, it's a problem. But you can scale vertically, meaning if a server has this capacity, you can double the capacity, whatever, no problem, okay? SQL databases are best for multi-row transaction type of databases, meaning you have a bunch of records, you know, in kind of in multi-rows, no problem, okay? SQL is going to be your preferred type of database you want to choose, okay? Now, for the non-SQL databases, like I said, there are quite a few types. There is documented, for example, Mongodb, where your records are, the way you create this, you have to create documents with the JSON syntax, but also there are graph and key value. There is also column oriented. Non-SQL databases are easier to scale horizontally, meaning if you had another server you wanted to add on server number 2 or 3 or 4, it's easier to do that because you don't have to define the structure in advance, how the different records, blah blah blah, are interconnected with non-SQL databases. Okay, it's fairly easier for them to scale horizontally in that way. Now, they also, for that reason, they tend to be also faster because that's the nature of these non-SQL databases. When do you use non-SQL as opposed to, say, SQL databases? If you have unstructured data that you want to work with, non-SQL databases are your choice to go with, okay? That's it for the theory. Let's get started with the hands-on, okay? To get started, first of all, you want to make sure you have your MySQL server downloaded on your on your machine. For me, I'm running Ubuntu operating system, and the way to install this is you run the command sudo apt install and MySQL, okay, server, and then hit enter. Okay, so you do sudo apt install MySQL server and hit enter. But I already have it installed, and to check MySQL space version. Okay, if you have it installed, when you run the command MySQL -- version, you're gonna get the version of the MySQL that you're running. Okay, as you can see, I already have it, and as a matter of fact, I can check the status. Okay, I'm gonna check the status of MySQL on my computer. It's asking for my root privilege password. As you can see, we have it running. Okay, perfect. Control C to exit. And today we are going to use the MySQL, being the SQL type of database. In the next video, I will show you how to do the non-SQL database like MongoDB. Okay, but today let's talk about MySQL. Now, Another thing I want you to go ahead and download is my SQL workbench. Okay, my SQL workbench is an application. It's a development application that allows you to work with your databases in an easier way. Instead of going to the CLI of the server, you can use your workbench, MySQL workbench, to create, delete, update your records or whatever you have on your server, on your MySQL, whatever you have on your MySQL server. Okay, I'm going to include links of these two to these two places where videos showing you how to install MySQL and MySQL workbench. Okay, matter of fact, let's see version. Okay, give it a second. As you can see, I already have it installed. Okay, perfect. Now let's get it fired up. So I'm going to start my SQL workbench. Perfect. Now the first thing I want to do is click on that. Now I'm connected. The first thing you're going to notice is we don't have anything opened, but I can create this blank tab. Okay, but I already have one opened here. Okay, the first thing I want to show you is that there are these keywords, special keywords that my SQL is going to interpret as special keywords, and those are highlighted in blue. Okay, an example of that is select, the word select, and the word like database, the word like as, no, integer. All of these are highlighted in blue, and this is to tell you that these are special keywords. Okay, and everything else like name of your tables, the name of your columns, preferably I like to keep them in lowercase so that I can tell them apart from these special keywords. Okay, and also notice that the special keywords I just showed you here, it doesn't matter if they are in uppercase or not. Okay, if I say select, it would still highlight that as a special keyword. So uppercase or lowercase, it doesn't matter with MySQL. Okay, but to keep things simple and uniform, it's a good practice to keep the special keywords in all uppercase. Okay, all right, let's get started. Now let's create our first database. Okay, the way to create a database, you start with the command create and then database, and let's call our database SQL and city. Okay, a company that I work for, city, SQL city. And so we just created our our first database here, and to run this command, I have two options here. The first option, notice the little Thunderbolt symbol or icon up here, and then there's another one on the right hand side of it, that this one has a cursor symbol. Okay, I prefer to use the one with the cursor because with that you can run one statement, one single line individually, but if you want to run a bunch of lines, 3, 4, 5, 10, whatever, at the same time you want to use the other one. Okay, the bolt symbol without a cursor sign. But I like the cursor sign one because I can place the cursor on the one statement I just want to run and only execute that one statement. Okay, in this case we want to execute on this one statement here, so I'm going to go ahead and hit that symbol right there, the bold symbol with the cursor, and just like that, we just created our database, SQL underscore city. I'm gonna refresh on the left hand side, and there it is. Okay, as you can see, we have our database showing up in the list of available databases that we've created. Okay, as a matter of fact, if we did show databases, okay, run this command, let's see what we get. Guess what? Our SQL underscore city is part of the available databases on this server. Okay, now let's go ahead and use this database. Okay, let's go ahead and create tables and add some content to the table, to those tables. Okay, but before you do that, you have to use the command use, and we have to specify the name of the database you want to use. Okay, so in this case, it's going to be SQL underscore city. Okay, that's what we want to use right now. I'm going to go ahead and execute on this command. Run that. Okay, now we have entered the mode to be able to add tables and content, whatever, to this SQL underscore city database. So the first thing you want to do is create your tables. Okay, we're going to have two tables. One table for the departments. The table of departments has a bunch of different departments names added to the table, and then another table is named employee, and the employee table is going to have the employee names, their job titles, the date they were hired, and their salaries and things of that nature. Okay, let's create our first table. Okay, create table. Let's call this department. Okay, the name of tables, I want to keep them in lowercase like that, so that I can differentiate them from the special keywords. Okay, the ones that are highlighted in blue. Okay, now we're gonna open up two parentheses. Okay, here, and then here we're gonna add our columns. So the table department is going to have the first column as department code. The code, okay, every department has a special code, and this is going to be an integer. Okay, this column is gonna be holding numbers. Okay, like 10, 20, 30, whatever. So we have to define the type for this field. In this case, it's an integer type, and it's going to be 2 digits to be specific. Okay, and comma. The next one is going to be the department name. Okay, this is going to be a variable, meaning it's going to be a string. Okay, a bunch of characters, let's say 50. Okay, comma, next one is going to be the location where the department is located. Okay, var char. Remember what I told you about SQL databases? You have to define your tables and the type of content they're going to have. In this case, you know, whether they're going to be integers like numbers or strings, whatever. Okay, you have to define the schema in advance. Okay, before you start adding content to those tables, as opposed to non-SQLs where you don't have to do this. Okay, so it's going to be 50 and primary. Okay, the next one is primary key, and the primary key is going to be of these 3 columns. We want the department code to be the primary key for this table. Okay, now we are done creating the department table. Let's go ahead and run this command, create table department command. Put the cursor on the top of that and then hit the execute button. Let's see what we got. Okay, refresh here on the far left hand side, And if you go to your SQL database, click on your table, list of available tables, you can see that we have the department table, which is available right there. Okay, now let's go ahead and add another table, this time for the employees. Okay, employee table. So create table. Okay, we're gonna name this table employee. Let's go ahead and add some columns. First column that we're going to have is the employee code, going to be an integer of size of 4. This one is not going to be null, meaning cannot be empty. Okay, this column has to have content. Okay, has to have an entry. Okay, okay, the next one is going to be the first name of the employee. This is going to be a string. Okay, text, size 15. Okay, next, last name, and it's going to be a variable character, size 15. And I'm gonna go ahead and speed up this part. When I get to the end, I'm gonna explain to you what I got. Okay, okay, now what we have here is we finished adding columns to the employee table here, and we've added the employee code, the first name, the last name, job title, the date of hire, salary column, the bonus column, and the department of which the employee is going to be part of. And we went ahead and said that the employee code, the first column, is going to be the primary key for this table. Okay, now we went ahead and defined our foreign key, meaning we are going to link the employee table to the department table through this foreign key statement right here. And we went ahead and said that whatever the department code we have here in this column, let that be the linking element towards the other table. And we want that to reference the department table in the department code table. So meaning this column right here from the employee table, we want that to reference the foreign table column, this one right here, the department code. Okay, remember, that's why we say that SQL, databases are relational databases, meaning tables are related to each other, so that you can call on whatever content you have in one table, and you can do different operations or whatever through these linking that is kind of predefined ahead of time. Okay, perfect. Now let's go ahead and execute this command. Okay, and add content to the table here. Okay, and let's do that. Refresh. On the left hand side, as you can see, our SQL _city database has the department and the employee as tables. Okay, and the employee table has a bunch of columns, and those are your employee code, first, last, job, hire date, salary, bonus, department code. Okay, and the department column has your department code, department name, and location. Okay, and also notice right under these you have the indexes here where you defined your primary key, and if you scroll down you have the indexes, the employee table. It defined, as you can see here, it says the department code is your foreign key here. See, employee table is linked up with the department table through this indexing that's happening here. Okay, perfect. Let's query our database here and see what we got. So we select star. Star here means every column, okay, all columns from the table department, for example, and we run that, and as you can see, we have our department columns defined. Okay, we have the department code, we have the department name, we have your location. Okay, now what about the employee table? Can we query that table and see what columns we got? Let's run that. Guess what? We got the results here. The employee code, first name, last name, job, hire date, salary, bonus, department, code. Perfect. We know our tables have been created successfully. Now let's go ahead and add some content. Before I do that, let me show you how you can add a column or remove it as you wish. Okay, let me show you how you do that. Okay, in order to add a new column to a table, you want to do the command alter, like alter the table. So we want to alter the table, and we want to target the employee table. What do we want to do? We want to say add a column. Okay, we want to add a column named date of birth. Okay, and it's going to be a date, and after say last name. Okay, so we want to add a new column after the column last name to the employee table. Okay, that's the syntax. Now let's run that, and let's run again the select command here to display the table again. Okay, look at that. We got the employee code, first name, last name. Guess what comes afterwards? The date of birth table. Column. Okay, the new column we just added with this command right here. Perfect. Now let's go ahead and remove that. How do you remove that? Again, you run the command alter. So we're gonna alter the table, and the employee code, the employee table. This time, instead of adding, we're gonna drop the command drop column. And which column do we want to drop? The date of birth, semicolon. So we're going to alter the table, employee, and what do we want to do? Instead of adding, we want to drop one column. So we go ahead and execute that. Okay, run again this command, the select. We're going to select all tables. We're going to select all columns from the employee table, and let's see what we got now. Look at that. After last name, the DOB, date of birth column is gone. Okay, we just removed it with this command here. Now, next, let's go ahead and insert values into the department table. Okay, the way to do that is insert into the department. We're gonna add values, and our first value is going to be the department code is 10, and this department is going to be networking, and the location. What was the second column? Second column was the third column was location. This is going to be Irving in Texas. Okay, and then comma, and a second entry, okay, is going to be 20, and the department name is going to be site reliability engineering, and located in Jacksonville, Florida. Okay, And third department is going to be department code 30 and sales, and it's going to be located in New York. Our fourth and last department is going to be the department code 40 marketing, and it's going to be Houston location. And notice that for strings we have to enclose those in quotes, okay, because they're strings. But for numbers, we just plain text, plain numbers, okay. And at the end everything with a semicolon, then execute this command, okay, the insert command. Hit that. Let's go ahead and query. Let's query our table and see what we got. We're gonna select all columns, department table, execute. Look what we got. Okay, we got networking, SRE, site reliability engineering, sales, marketing, locations, department code 10, 20, 30, 40. Perfect. Okay, let's go ahead and do the same and add, this time let's do let's insert into the employee table. Let's add some values to the employee table. Okay, our first employee is going to be his name is going to be the first where is it that we what was the first column for the employee table? Let's find out. So select all columns from the employee table, and let's execute that. Let's remove this command here for now. So okay, execute that again. Now, as you can see, we have the employee code being the first table. So back to the insert into the employee table command. Our first value is going to be the employee code, and we want this employee to have 9368 as the employee code, and the second one is his first name. Okay, the first column is the first name. His first name is going to be John. Third column is going to be last name, John Doe, last name Doe, and the next column is the job title. Okay, he's just a regular engineer. Okay, just an engineer, and the year of hire, he was hired in 1976. 10. Okay, 1970, June 10th. Okay, and then the next column is the salary command. The salary column, which has, let's give him a salary of 100,000. Okay, so 5 zeros, and annual bonus of say 10,000. Okay, and he belongs to the department SRE. Okay, SRE right here with the department code number 20, which is the last column of the employee table as well. Okay, so we have our first entry into the table. Let's go ahead and add a bunch more employees, and for this part I'm gonna speed up this part, and I'll show you at the end when I have finished entering the rest of the other employees. Okay, all right, let's go. Okay, now I went ahead and added a bunch of employees to the employee table. As you can see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, a total of 9 employees in this table. And with different names, titles, date of hire, and salaries, bonuses, and different department that they're part of. Okay, now let's go ahead and execute this command here to add that to the employee table. Okay, now let's query again the employee table, see what we got. Select all columns from the employee table, hit the execute button, and let me move this up. Look what we got. See, beautiful. The employee code, first name, last name, job title, the date of hire, salary, bonus, and department that they're part of. Perfect. Isn't that beautiful? Now we have both tables populated. Now we have the employee table and the department table also populated with the different departments. Okay, perfect. Now next I want to show you how you can change a record of a table to whatever you want. Okay, let me show you what I mean. So we are going to update this guy right here, 93, this guy 9254, the guy with 9254 as the employee code. We are going to change the first name from Tim to my name Jimmy, and then last name to my name Shaka. Okay, Shaka. Let's do that. Update. We're going to update the employee table, and we want to set the first name. We want to set the first name to my name Jimmy. Okay, and we want to do the same for the last name, and we want to set that to Shaka, where the employee code is, what's the code that we want to replace? 9254. So this 9254, that record that has the employee code of 9254 is what we are referencing here, up here. Okay, so, and with the semicolon, let's execute this. Notice that the guy here, Tim Wilson, will be removed from the employee table and replaced by Jimmy Shaka. So execute, and let's select again, query the tables, all columns from the employee table. Look what we got. The first guy has been removed and replaced by Jimmy Shaka. Perfect. Now, what else can we do with the select command? What we could do is we could say we can count. Let me show you. Select count. We want to count how many employees. The employee code from the employee table. Where you have the option to specify where you want to execute this query on. We want to only select or choose records that have department code being equal to 20, or otherwise SRE, site reliability engineering, which is with the code 20. So we say select and count, count those employees that are part of the employee table where the department is 20. Execute that command. What do we have? The count is 3. There's a total of 3 employees part of the SRE department. Okay, site reliability engineering. What are those? This guy, the first record, this, and that. Okay, 3, total of 3. Okay, What else? What else could we do? We could also say select. We could do the same here, and let me show you some complex querying. So select department code, okay, and what do we want to do? We want to count the department code, and from the employee table. Okay, what do we want to do afterwards? We want to group our query results by department code, and semicolon. Let's execute this. See what we got. Look what we got. We were saying there is, for the department ending, number 10, there is a total of 2 employees. Department 20 got 3 employees. Department 30, 3 employees. Department 40, 1 employee. That's what we did here. Okay, we're selecting the department codes. Okay, and then we are counting how many there are for each group, and returning the result in a table showing just those 2 columns. Okay, the department code and the count. This count function is what we call the aggregate function here. Okay, perfect. And obviously you can do much more than that. Let me give you another example here. I just have this command typed out on my notepad. So I'm gonna go ahead and copy that and paste it here. I'm gonna copy that from my notes on my notepad and paste it here. So what we're going to do here is we are going to select, okay, and then this function here is going to concatenate. Concatenate is mean in table operations, whatever, is to join. Okay, so we're going to concatenate our first name and the last name. Let me run that first, and then I will explain to you what I mean here. Look what we got here. We got the guys' names, the employee names, and their total salary. Okay, bonus plus the best salary, and these are the names, first and last name. And notice the name of the columns here. It says full name, and then the other one says total salary. Okay, isn't that beautiful? Now, how do we do that? How did we do that? We use the concatenate function with the option of defining what's the separator. Okay, the separator here is the space. That's why we have the space between our names, first name and last name. There's the space here. Okay, that's why we say it here. We want the space to be that. And let me show you. If you put a plus sign, okay, and execute that, guess what you're gonna have? You're gonna have the plus sign in between the names. Right? Okay, so let's go ahead and remove that again. We want some blank space between the first and the last name, and execute the command here, and we got our table with the first name, last name, full name, okay, with the total compensation. Okay, so we got that part, and we want our selection to be represented as full name. That's why we have the column name here, full name. Okay, and what do we want to do afterwards? As another aggregate function, we want to sum the base salary plus bonuses. Okay, and we want those represented as a total salary. Okay, where from the employee table, how do we want to group these? Group by full name. Okay, that's another kind of interesting complex query we just did here. Okay, beautiful. Another one I have here in my notes, my notepad. Let me go ahead and copy and paste here, share with you. The next one will be this one here. and let me go ahead and run it. This time, notice we have only 6 employees as opposed to 9. These are the only employees that have a total salary, total compensation, base salary plus bonus above 100,000. Those that do not have total compensation above 100,000 are not showing up here in this selection, okay? Because that's what we said. We are interested in only those that have their total compensation being above 100,000. Okay, cool. And we want the table title to be named total earners. Okay, this is it right here, the total earners table there. Okay, next, another one that I have here in my notes is what if you want to see the maximum, the average, and etc, etc. So we do that, select average salary, and we want that represented as average salary, and mean salary, we want that represented as mean salary, max salary as max salary from the employee table. Hit enter. Guess what we got? Of all the employees, the average salary is 102,000, and minimum is 70,000, and maximum was 150,000. Beautiful. Okay, this is just to show you that you have a bunch of options of operations you could do when querying your tables. Okay, now what's another one? What's another cool one we could do here? Let me go ahead and select this one from my notes, and I'll show you here. Paste it here. Now remember, we have the employee table and the so we have the employee, select all columns. We want to select all columns from the employee table. Okay, let me run this command. Okay, we have all columns, for the employee table. Okay, all columns are represented here. Same thing for, instead of employee, we have the department. Okay, run that. Here's the department table. Now the next command that I want to show you is with relational databases like this, you have the option of joining your tables, one table here, the next one starting from there, and you have all of your information represented in one giant table. Okay, there are different ways of joining. You can left join, you can right join, and then you can do the default one, which is inner join, which I just did here. Okay, and I can remove the inner, it would still work. It's all the same. Okay, now we are going to join, so we are going to select all columns, well, the star here means all columns from the employee table. Okay, and we want the department column, okay, to be joined to the employee table. Okay, let's hit the run command. Let's see what we got here. Look, we got our employee table from 1, 2, 3, 4 all the way to the department code. Notice what happens afterwards. The department code starts networking, location, Irving. The next guy, Dan Smith, manager, blah 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 blah. He's part of department code 20. He's SRE, site reliability engineering, and etc. Jacksonville. So how did this do this? How were we able to do this? Okay, so basically what this did was it joined these two tables, but it made sure that to compare the department code from the employee table to the department code from the department table, so that wherever there's a match, to go ahead and join those tables. So there was a 10 here, from the 10 here from the employee table was joined to the other 10 from the department of the department table, therefore pulling in the department name and the location based on that 10 being the joining element. Okay, same thing for the 20, for the 30, etc., etc. Beautiful. Okay, you can do other things like what if you want to remove say a record. Okay, you can delete records from your tables just as simple as adding them. Okay, how can you do that? For example, let's say we want to remove our guy here, 64. Okay, let me show you the whole table first. Employee. Okay, let's go ahead and remove this guy here, John Doe 9368. Okay, the guy with the record number, employee ID number 9368. John Doe. Okay, so the way you do that, you come here, you can do that 9368, delete from the employee table where the employee code is 9368. Run that, and if you run the select command here up again, the select command from employee that we have up here, you run that again, guess what? John Doe is gone. We don't have a John Doe here anymore. See, John Doe is gone. We're now left with 8 employees instead of total of 9 that we originally had. Okay, perfect. You can also use other different filtering keywords like between, all sorts of filtering options that you really have with SQL databases. For example, between here, we're going to select all employees where the salary is between 100,000 and 200,000. Let's run that. Guess what? How many is that? Is a total of 4. Only 4 employees have a salary above 100,000. See, just these 4 out of the 8 that we are left with. Okay, after removing John. Perfect. This is pretty much everything that you need to know, like 90% of things you need to know about MySQL and the SQL type of databases. And I'm gonna put a link here under the video in the YouTube description section, and make sure to check that out. I'm gonna share the link to this place where you have the different other functions that you could be running, or different options that you could use to query, to do some complex querying. Okay, and also all of the other interesting and useful links. I'm going to be sharing them here in the description section. Next up, I want to cover the non-SQL databases like Mongodb. Stay tuned. It's going to be an interesting one. Okay, thank you for watching. As always, bye bye.